Okay, so let's revisit this IVP. Y prime minus 2xy is equal to 2x, subject to y of 0 is equal to 2. In this instance, I want to solve it as a linear ODE because I also notice that it's in linear form. We'll find that some first order ODEs are both linear and separable. Some are neither linear nor separable. Some are strictly linear and some are strictly separable. Okay, so let's go ahead and try the linear technique on this initial value problem. So the first thing I want to do is I want to recognize the p of x function, and from there I'll find the integrating factor. My integrating factor is going to be e to the integral of p of x dx, so it becomes a minus 2x dx. In this instance, I get e to the negative x squared. And if I go back to my ODE and multiply through by the integrating factor, I'll get e to the negative x squared y prime minus 2xy e to the minus x squared equals 2x e to the minus x squared. And again, the great thing about the integrating factor is that on the left hand side we've set up the product rule such that now I could write the left hand side as d by dx of the function y of x times the integrating factor, e to the minus x squared. And on the right hand side I have 2x e to the minus x squared. So now I should be able to integrate both sides with respect to x. And on the left hand side, according to the first fundamental theorem of calculus, I should just end up with ye to the minus x squared. And on the right hand side, a basic substitution, let's say I let u equal to this minus x squared, then du by dx will be a minus 2x, or du is a minus 2x dx. So I guess I could write a minus du. We'll pick up the 2x dx. So the 2x dx, I'll substitute in with a minus du, and this minus x squared, I'll substitute in with u. So this just becomes the integral of e to the u, and I have a minus du, so I'll put the du here and maybe the minus sign out front. The integral of e to the u is e to the u, so I'll get a minus e to the u plus some constant c. Let's just go ahead and place the minus x squared back in for u, and I get a minus e to the minus x squared plus c. Now let's divide everything through, because remember I still want to get this y by itself, so I want to divide everything through by e to the minus x squared, or I could multiply both sides by e to the positive x squared. I get y of x equals minus 1 plus ce to the positive x squared. Okay, and at this point let's apply y of 0 is equal to 2. Let me see, I'll get 2 is equal to a negative 1 plus c e to the 0, which is just a negative 1 plus c. In any case, let's see that c is equal to 3, and if I plug that back in, I should get my y of x equals negative 1 plus 3e to the x squared.